The goal of this video is to understand chemical and physical properties. But in order to do that, we first need to consider chemical and physical changes. And to do that, we need to understand what change looks like. So, a property is just a distinguishing characteristic of a substance that is used in its identification and description. For example, we could describe water as being a clear, colorless liquid. Clear, colorless, and liquid are properties. There are two kinds of properties: physical properties and chemical properties. In order to understand properties, we need to understand changes. A chemical change is a change in what something is. A physical change is a change in where something is. And so we can begin by considering just a common butane lighter. The fuel in the common lighter is butane. And if you depress the tab without moving the striker, the liquid inside escapes. But what we had before and after is the same smallest unit. Therefore, that is a physical change, a change in where something is. A chemical change occurs when the striker is engaged and butane liquid combusts. We begin with butane inside the lighter escaping through the valve, combines with oxygen in the air, and the striker allows bonds to break and new bonds to form, and what we have afterward, carbon dioxide and water vapor, are different. The smallest unit before and after are different. That is a chemical change. In order to understand chemical and physical changes, we need to first consider, how do we know changes happened? And so in our class, there are going to be these 6 evidences of change. Bubbles form, solid forms, solid disappears, color changes, the temperature changes, or the smell changes. And many times several of these happen at once. When this change happens, is that chemical or physical? It could be either. What matters is, did the smallest unit change? For the first one, bubbles form. You know that if you add heat to water, if you put a pot on the stove and heat it up, the water vaporizes, it becomes a gas. But what you have before, H2O, and what you have after, H2O, the smallest unit is the same. So that makes a physical change. A chemical change, where bubbles form, and that's the evidence of change, could be something like adding acid to a metal. Most metals are acid reactive, and when they react, they produce a gas, hydrogen gas, which is flammable. And in this case, because the metal is zinc, zinc chloride would be the other product. If what we had before and after are different, then that is a chemical change. The hydrogen that is produced from the metal reacting with acid, that hydrogen can combine with oxygen in the air. And so we begin with a mixture of 2 elements. But if bonds break and new bonds form, we end up with a different product, chemical change. The second evidence of change would be a solid forming. You know that if you put liquid water in the freezer, the energy is removed, the water slows down and sticks together, and you end up with solid water. But the smallest unit, H2O, is the same before and after. That's a physical change. However, if you are to combine some reagents, a solution of silver nitrate and a solution of sodium carbonate, can react to form a solid, silver carbonate. If the solid formed has a different chemical formula, is a different smallest unit from what the reactants were, that is a chemical change. A third evidence of change would be solid disappearing. If you had a packet of Kool-Aid, so Kool-Aid is a solid, a mixture of solids, and you put it in water, You would now have the solid dissolve. We have an aqueous solution, but the smallest units in the mixture that make up Kool-Aid. So maybe citric acid, flavor, red dye number 4, preservative, all those same things being put in the presence of water have not changed. We still have sugar, it's just now dissolved in water and we can't see it. But if we start with a solid, and in the end we have no solid, and the smallest units have changed, that's a chemical change. Magnesium, like zinc, is a metal. And many metals react with acid to produce hydrogen gas. Magnesium and hydrochloric acid react to make magnesium chloride and hydrogen. The fourth evidence of change would be color change. In the previous example, I said if you put Kool-Aid in water, the particles that make up the mixture that we call Kool-Aid are all the same before and after, but they're spread out by the presence of water. And so whatever the intensity of the color is before is going to be less intense after. The color hasn't really changed, it's become less intense. But it is possible to put copper 2 ion in water and add aqueous ammonia, and what was a sort of cyan-colored copper 2 blue before becomes a deep royal blue after, a different color blue. That's evidence of a chemical change. Temperature change is the fifth evidence of change. Anytime we have a physical or a chemical change, there is usually a temperature change, but it may be so subtle that we don't perceive it. Water is heated. We start with room temperature water. We add some energy, and it gets hotter. But sometimes we mix things that are room temperature, like hydrochloric acid and sodium hydroxide. And in the process of chemical change, the formation of water and salt, there is a change in energy that is noticeable. Unfortunately, we can't feel this one because we're not in the lab to pass around the materials. So you're just going to have to trust me on that. Another evidence of change that we can't perceive through Zoom or YouTube videos is smell change. But it's similar to the Kool-Aid example. You can spritz a spritz of perfume in one corner of a room, and over time the perfume spreads out. And we can smell perfume maybe across the hall that we didn't smell before. It's not that the smell changed, it's just that the smell spread out and reached our nose. So that could be a physical change. But sometimes when we mix reagents like ammonium chloride and sodium hydroxide, there is a chemical change that produces a species that does have a smell. So this smell is different, ammonia. So in the process of this chemical change, one of the products contains an odor that wasn't present before the reaction occurred. Those are the 6 evidences of change. Does that mean it was a physical change or a chemical change? Depends. We have to consider the smallest unit. One thing to note is there are 2 kinds of physical changes, and physical changes are reversible. A liquid that was frozen by removing heat, so liquid becomes solid, can be melted, solid become liquid, by adding heat. If we do the opposite process, we get back what we started with. So a liquid becoming a solid and a solid becoming a liquid, this example is an example that we call change of state. And change of states are physical changes. Or perhaps we had a solid and like salt, and it was put in water. The solid dissolved in water is a physical change. And it is possible to separate those things again by evaporating the water, leaving the salt behind. A second kind of physical change is mixing or unmixing, separating. Chemical changes involve a change in a composition. So the substance, what you have now, is different than what you started with. You cannot easily get back your original substance because something new has been formed.
In this experiment, we will first make a mixture of black iron filings and yellow sulfur powder. Black iron filings and yellow sulfur powder are thoroughly mixed. They form a gray mixture of the two elements. This mixture can be separated by physical methods. For example, when a magnet is brought to the mixture, it removes essentially all the iron filings, leaving the sulfur behind, which here looks gray because of the impurities from the iron. The iron has been separated from the sulfur by means of a magnet. When the same mixture is heated in a test tube, the two elements iron and sulfur react together to form a new compound, iron sulfide. At first, when the mixture is heated, the sulfur melts. Eventually, as the heating continues, the iron and sulfur begin to react together. When the Bunsen is removed, the tube continues to glow as the reaction proceeds. The gray-black brittle solid formed is a new compound, iron sulfide. It is unlike either sulfur or iron and cannot be separated by a magnet.
In that video, at first, solid iron and solid sulfur were mixed. So we had black iron filings and yellow sulfur powder before, and afterward we had a mixture that was gray, or a mixture of those two colors. But the smallest unit didn't change. But when it was heated, there was a chemical change that occurred. We had an element that was a metal, another element that was a nonmetal, but after heat was introduced, there was a chemical change, and we ended up with something that is a compound. Something I can find on the periodic table with one letter, that's an element. Something else I can find on the periodic table, one capital letter, also an element. But in the end, those things are chemically combined. Two capitals, that's a compound. So here is a pop quiz. We're not going to do it now, but you do need to consider all of these. There will be a quiz this week on chemical and physical changes, and these 8 examples will be in that quiz. So you need to consider: a puddle of water evaporates. Is that chemical or physical? After you've come up with your 8 answers, P or C, if you're not sure about any of them, feel free to email me. So you need to do this on your own before you take the quiz this week. And you need to ask questions if you have them before the quiz. Okay, there are 2 kinds of physical changes. A physical change is a change in where something is, how the smallest units are oriented with each other. Are they next to each other, or are they spread out? There are 2 kinds. One is change of state. There are 6 change of state terms that you need to know. And the second kind would be making or unmaking a mixture. So the smallest unit, it may be an atom or molecule, or it could be an ion, which is an idea that we haven't discussed yet. An example of an atom would be a monatomic element, like neon. An example of a molecule, water. And then ions are charged particles. So sodium metal can lose an electron and become sodium ion. Chlorine, which is a nonmetal, can gain electrons and become chloride. And then when these two combine, we call that sodium chloride, which is also known as table salt. Change of state is also known as physical change. It's the conversion of a substance from one state, solid, liquid, or gas, to another, solid, liquid, or gas. But the smallest unit does not change, so change of state is a physical change. And because these are common phenomena, there are common words for these changes. So before you take your quiz this week, you need to read the text and figure out what the change of state is from solid to liquid, liquid to solid, etc. For example, for solid to liquid, there is a common name. We would say, oh, that melted. So the phase change from solid to liquid could be called melting. But in chemistry, we have a special chemistry word, which is fusion. So some of the words are common and familiar, and you know them, melting. Some of the words may be new to you, fusion. And these can be found in your text. So change of state is one kind of physical change. The other is either the forming or the unforming of a mixture. On the left, we have a magnet and a mixture containing potassium dichromate and iron filings. Because iron reacts to magnets, this can be physically separated by the use of the magnet. So the magnet can be used to separate the iron filings from the potassium dichromate. The unmixing of this mixture by the use of a magnet on iron, that is a physical change. The smallest unit hasn't changed. They're just the two kinds of things are being separated. Here we have a chemical change. The picture on the left is the before, and the before is written to the left of the arrow. So here we have nickel shot and hydrochloric acid. And you can see evidence of change when you look at the picture on the right, which is the products. When we speak what happened, we use words like reacted to form, and then we state the products, nickel 2 chloride and hydrogen gas. In chemistry, we are able to use symbols and formulas to represent these words. So I would say nickel and hydrochloric acid react to form nickel 2 chloride and hydrogen gas. There are several evidences of change in this picture. One is really obvious. There's a color change, but can you find two more? Sodium metal and chlorine gas. We begin with two elements and we end with one compound. It is a chemical change. And as this chemical change occurs, there's a huge release of energy. It's very exothermic.
This reaction can be safely demonstrated in school. In this case, chlorine has been placed in a flask, and some sand is used to protect the glass from the heat produced in the reaction. A long syringe needle has been used to pick up a small piece of sodium, and using the glass tube, it is dropped into the sand. The syringe is then used to deliver a few drops of water, which causes the sodium to ignite and then react with the chlorine. The product is sodium chloride, which appears white only when excess chlorine has been removed from the flask.
So we've looked at physical and chemical change, what change looks like There are 6 evidences of change. What physical change is, a change in where something is, versus chemical change, a change in what something is. And now we're ready to talk about properties. A property is a descriptor, a characteristic used to describe. Some properties are physical and some properties are chemical. Now we're ready to look at properties. We can tell if a property is physical or chemical by how we observe or measure it. In the process of observing or measuring this property, did the smallest unit change? If not, it is a physical property. A physical property is observed or measured without changing the identity of the substance. Determining the physical property does not change the smallest unit. There are many examples of physical properties. There are more physical properties than chemical properties. Can I know the boiling point of a substance without changing it? Sure. I have liquid water. I want to know the temperature at which it boils. I put it on a stove and heat it up and stick a thermometer in there. And when I get to the temperature at which liquid water becomes gaseous water, that temperature is called the boiling point. We have the same substance before and after the smallest unit didn't change. That's a physical property, boiling point. Density is also a physical property. In order to know the density of a substance, we would need information about the mass of a certain volume of that substance. We can measure the mass on a balance without changing the substance. We can measure the volume without changing the substance. Therefore, density is a property that can be known without changing the smallest unit. That makes it a physical property. Conductivity is difficult sometimes for students to appreciate, but let's think about, what do you have in your home that conducts electricity? Copper wire. You plug things in and the electrons run through the copper wire and power your devices. How often do you have to change the copper wire in your home? Is it every 5 years, every 10 years? No. Hopefully you never have to change the copper wire in your home, because the process of conducting electricity doesn't change the smallest unit. Copper before as a solid, copper after as a solid. Electrons have simply gone through it. Conductivity, electrical and thermal, is a physical property. Most properties are physical properties. A chemical property can only be observed or measured by changing the identity of the substance. Determining a chemical property changes the smallest unit. For example, flammability. Is this piece of paper flammable? Here, let me light it on fire. Yes. We had paper before. Do we have paper after? No, now we have soot. So in the process of determining that a piece of paper was flammable, the paper was changed. Most metals are acid reactive. If I put zinc in hydrochloric acid, hydrogen gas is formed. So a chemical property could be acid reactivity. But if the property is chemical, the unproperty is chemical too. So acid reactivity is a property that many metals have, but some metals don't. Gold, for example, if you pour hydrochloric acid on a gold ring, there is no reaction. Nothing happens. There are some metals that are pretty inert, and we use them for coinage and jewelry. We call those the money metals. Gold, silver, copper are not acid reactive. But acid reactivity is a chemical property, whether it happens or whether it doesn't happen. Being reactive or being inert is a chemical property. To summarize, matter can be classified by its chemical and physical properties. And changes can be classified also as physical or chemical. In both cases, the pertinent question is, did the smallest unit change? Thank you for your time.